Hello everyone, this is Gordon, and this is the first set of problems relating to laws of motion, classical mechanics. The three laws of motion: velocity of an object is constant without non-zero net force. In other words, an object at rest will stay at rest, an object in motion will stay in motion. The second one, force is equal to mass times acceleration. The third one, no force occurs by itself. The standard way to say that: for every action, there's an equal and opposite reaction. We're asking the first problem for a book that rests on a table to diagram the forces acting on the table. This is important. We need to know how to diagram problems in order to visually see what it is that we need to calculate. And so diagramming things out is always a good way to start. We can take a look at this poorly drawn table. See the book resting on it, the table resting on the ground. And of course, the book has mass and therefore weight and creates a force on the table. The table itself has mass, therefore weight, and force provides force to the ground. And so we have, as a result, these forces: the force of the book on the table, the reaction force by the table, the force of the table on the floor, and the reaction force of the floor on the table given by A, B, C, D, E, and F. And that's the first problem. The second problem: a 10-kilogram body is observed to have an acceleration of 5 meters per second squared. We're asked to determine the net force acting on the body. Mass is given as 10 kilograms and acceleration of 5 meters per second squared. And we're asked again to find the force. We use the second equation: force is equal to mass times acceleration. And so, substituting the numbers into the equation as given, we have 10 kilograms times 5 meters per second squared gives us a force of 50 newtons, a newton being a kilogram meter per second squared. Third problem: a force of 3,000 newtons is applied to a 1,500 kilogram car at rest. What is its acceleration and what will its velocity be in 5 seconds? We're given force as 3,000 newtons, mass 1,500 kilograms. We're asked to find A, and we're asked to find V in 5 seconds. We have the equation: force is equal to mass times acceleration. We can rewrite that as acceleration is force divided by mass. Substituting our numbers in, we have 3,000 newtons divided by 1,500 kilograms, and the answer, 2 meters per second squared. And from our earlier problem set, velocity in 5 seconds is acceleration times time, 2 meters per second squared times 5 seconds. The velocity at time equals 5 seconds will be 10 meters per second. The fourth problem in this set: a 1,000 kilogram car goes from 10 meters per second to 20 meters per second in 5 seconds. We're asked to find the force acting on it. We have mass, 1,000 kilograms, initial velocity, 10 meters per second, final velocity, 20 meters per second, and time as 5 seconds. Force is mass times acceleration. We know what the mass is. We need to determine the acceleration with the remaining information that we're given from an earlier problem set. Acceleration is the difference in velocities over a certain period of time. And so we have 20 meters per second minus 10 meters per second divided by the time given, 5 seconds. Do the arithmetic, and we get an acceleration of 2 meters per second squared. So the force on the 1,000 kilogram car, mass times acceleration, 1,000 kilograms times 2 meters per second squared, providing a force of 2,000 newtons. The fifth problem and final problem for the set: a box is sliding down a frictionless plane inclined at 30 degrees. What is the acceleration of the box? We're given theta as 30, and that's it. We're asked to find the acceleration. We're going to use force is equal to mass times acceleration and draw a diagram to represent what's going on. We have the ground, the ramp at 30 degrees, and the box. The box, of course, has a weight because it has mass, and it's always directed directly downwards towards the center of the Earth. The weight is mass times gravitational constant, as is true for all objects on Earth. And that can be reduced to its components in the x and y direction. It's the F in the y direction that we're interested in, because that's the force that's providing the acceleration down the ramp. And so the force in the y direction is mass times acceleration in the y direction, which is equal to W times the sine of 30 from an earlier problem set. W is mass times acceleration, so we have mass times acceleration in the y direction is mass times acceleration times the sine of 30. The masses cancel. That A, of course, is a gravitational constant, 9.8 meters per second. And so the acceleration in the down the plane is 9.8 meters per second squared times 0.5 the sine of 30, or 4.9 meters per second squared. And that's it. Thanks for watching.